It's about to start, we'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is a continuation of what we have been doing last week, so get ready for more of me starting Reaper 1,000 times. Oh boy. Okay, for context, we have been working on a series of audio effects using the JSFX programming language in Reaper. We are in the middle of working on one effect called AutoMixer, but we are going nowhere near the AutoMixer today. We are now working on the infrastructure necessary for the parameters that will control the AutoMixer. And what we learned last week in this part of this exploration was that the serialized section in JSFX is wild. The purpose of the serialized section is for you to store and then restore data that your plugin may need. So plugin in JSFX will have a couple of sliders, and those will be stored by Reaper in the Reaper project when you save, and will be restored by Reaper from the Reaper project when you reopen the project. But you may need to store data besides and beyond the default sliders. And then there is the serialized section in the JSFX code that allows you to store arbitrary data into the Reaper project file. What we learned is that it is a bit crazy the way that this works if you try to sort of extend or abuse it to store things like the version of the plugin so that you're able to migrate sliders when you update the plugin, and perhaps these sliders have different meaning now. You would like to shuffle some variables around. That is kind of abusing the serialized system, and it is a bit odd. For more detail and amazement, you can watch the previous stream on this channel. But what we learned is that the serialized section, in summary, is a bit crazy, and I'm going to try to avoid it, at least in this abuse sense. Storing version, storing globally synced parameters, those kinds of odd uses I will avoid. There may be some other uses that are more like vanilla, more like the thing that is expected from the serialized section, and those we can continue using if necessary. So for instance, in ReEQ, Justin Johnson had to store some regular parameters in the serialized section just because he has run out of sliders. When you have more than, I guess, 8 or 16 bands of an EQ, you run out of sliders in JSFX. There are only 64 of them, so the serialized section is your only bet. Anyway, we will stick to the more traditional use of the serialized section, and we'll look into what this means for the parameters that we want to have. Anyway, so Mage and Taylor here, hello. It's great to have you here. And Taylor sent me, I'm saying this so that he knows that I know, he sent me a great email with an attachment and everything, with a thorough explanation of everything that happens in the life cycle of a plugin, and that sort of illuminates some of the edge cases that we encountered last week. That's very useful, but I'm gonna try to avoid using the serialized section that way. I'm gonna try to avoid relying too much on the order of execution of the different sections of code in JSFX because it's odd. It's really weird. Anyway, I was going to do some JSFX experiment at the weekend, but then went down a TypeScript rabbit hole. That's fascinating because I love TypeScript. So I would love to hear what you have been working on or trying out. I think that TypeScript is really well designed. It's such a difficult problem to retrofit a type system into a language that doesn't have one and wasn't really designed with that in mind. So it is a really difficult project, and I think that they did a great job. I especially like the any type. That's my favorite type. I really like it. If you don't know what the any type is, it essentially turns off the type system. It's a type that doesn't really restrict the value in any way. And the reason why I like it is because in many cases you run into corners and you know what you are doing, but the time system doesn't. Happens often, especially in more strict languages like OCaml. And then it is awesome to be able to say to the type checker, please trust me on this one, let me do what I'm doing. And of course, you always want to revisit this decision and specify the types better later, but it's awesome that the any type exists. Anyway, creating plugins for Obsidian. I think that's the personal wiki kind of thing, right? That you use. Anyway, if you are running into weird TypeScript behavior, then let us know, because we may have something to say about that. At least I have some experience with TypeScript. It's the language we use for the server side of my day job. Course See, that's the kind of thing you do when you are the system administrator and developer of something. Anyway, Bo is here. Hello, Bo. Great to have you here. All right. So speaking of rabbit holes, let's dive into this. This is what we had last week. We explored the different places where parameters appear and the different actions or events that occur in the life cycle of a plugin in JSFX. And then we studied how we would like for the parameters to behave under these circumstances. We will now revisit this in light of what we learned last week about the serialize section and try to not use it. That's what we'll try to do. So I have two markers here, red and I guess let's use red and green. So red will be things that we want to get rid of, and green will be things that we need to pay particular attention to. Mage is playing with Teal as well, which is a typed subset of Lua. And Bo is trying the new AX chorus. I don't know what that's about. And I didn't know about Teal. And again, Lua is a language that hasn't been designed with the intent of having a type system, but Lua is a much smaller language and much saner and, let's say, better designed in many aspects. So creating a typed version of Lua seems more feasible than doing the same with JavaScript. Is AX chorus something that Tail designed? Because okay. Nice. Maybe I'll check it out later. So first, we want to get rid of the serialize section. We don't want to use it to coordinate our regular parameters, and we don't want to use it to do the globally synced parameters, which are the parameters that are linked between plugin instances. We want to try and get rid of that. And I guess the main reason for that is that it was really hard for us to tell apart the cases in which a plugin was first loading straight from the effects browser in Reaper and when a plugin was really being restored from an existing Reaper project. And we would like to know these two cases, and it may be possible, but it's really tricky. So we will try to avoid this, and we'll try to avoid that, because this question is hard to answer. And then we can get rid of these parts as well. Then anything that touches C that used to be our serialized can go as well. And in our little diagrams here, we have the different parts of the parameter and how they need to sync. But it seems as though C does not appear here on these diagrams. It only appeared on these diagrams. Great. So there is one thing that we need to pay attention to now. Now that we don't know how to distinguish cases 1 and 8, we will have to be smart about the way that we store stuff in gmem. The point of storing the parameter in gmem is that it allows us to sync that parameter across plugin instances, the linked parameters that we have on the Automixer. And now that we don't know if we are being loaded the first time or from the Reaper project, we will need to have some sort of flag in gmem itself. This flag will say whether that spot has been initialized or not. If it has been initialized, or I guess let's start with the case in which it has not been initialized, because that happens first chronologically. So a plugin will be loaded for the first time. Gmem will be just a bunch of zeros. So the flag will be false. And then what we'll do is copy into that place. Copy into gmem, and we will set that flag to true, like initialized. Alternatively, if gmem has that flag set and we are loading the plugin for the first time, then what we want to do is the opposite. We will consider that we are in this case. So that's the next best thing we can do, right? If we cannot tell in a principled manner whether we are being loaded for the first time or restored, what we'll do instead is have a flag in gmem. And I think that that will work out. But we'll have to pay special attention to this, because if E has been initialized, and E is the global memory, if it has been initialized, we don't want to do the arrow in this direction, we want to do it in the opposite direction. We will want to do something more like this. And the cool thing about this approach, this strategy, is that it sort of, to some extent, unifies two different cases that we explored last week. So for context, you will probably have to watch last week's stream because we are really deep here. But we found that when the plugin is loading for the first time, and that we know that because the init section is going to run, when that happens, we want to do this star procedure. I named it star. And that procedure is take the sliders, which will have their default values from the JS effects, just these sliders will have default values, and copy that into the derived parameters. I guess it's not exactly copying, it's computing the derived parameters. Copy them into the GFX notion of the parameter, and perhaps copy that into gmem. Except that now we learned that there is this other case in which the plugin is being loaded, but gmem is the source of truth. So in that case, we want to reverse this arrow. So that means that we need to generalize star to be aware of this reverse direction that may happen. So star here is another point that we need to, of course, take care of. But now that we need to take care of this, it actually unifies with this other case, which is the case of subsequent instances loading. And we will want to look at the gmem and copy into the sliders. So star and dagger became the same thing, became the same workflow, because we will need to look at gmem to know what to do. Yeah, perhaps this diagram is becoming so complicated that it will be easier to just try to implement this and the code will tell a better story than the diagram. But it was helpful to think about all this and have it on paper. And Mage is asking about Tails exploration. Maybe we should look at that. But Mage is asking why my code last week was working differently when this variable was set. What this variable does is tell JSFX to not run the init section multiple times. As far as I understand from having read Tails' email, the explanation is that the init section was not running once when the plugin loads, it was running twice. That's actually consistent with something we observed way in the past in other explorations. It seems as though the init section runs twice as soon as the plugin loads. Not really sure why, but that's what it does. So the init section was running twice. The first time it was doing the wrong thing, then the serialize section would run, and then the init section would run again, and it would do the right thing. And then when we set this flag, the init section is only going to run once, the first time before the serialize section, so it does the wrong thing. Yeah. But yeah, for our purposes, maybe later we will have to revisit this, but for our purposes of dealing with parameters, I'm not too worried about this lifecycle thing. I gave up on the lifecycle and I gave up on the serialize section for the most part. So we will just try and solve the problem of parameters without having to deal with this very tricky lifecycle situation that we have going on. The first thing that I want to do is actually another experiment, because I remember way back learning that you need a serialized section and you need one that is not empty for some other parameters to behave better. But I don't remember exactly what. I think it has to do with the sample rate being available on the init section. I know. Why? What's the relationship? I don't know. It's very tricky. But then, since I learned that I needed a serialized section, even if it was empty, or it cannot really be empty, but it can be a no-op, just like this. So when I learned that I needed a serialized section, I saw Geraint Love's recommendation of using this to store the version of a plugin for migration later. And then I said, well, okay, let's use that as the placeholder. But since I'm trying to avoid this and avoid any weird use of the serialized section, let's explore this tangent real quick. And these are leftovers from last week. So let's explore this tangent again, see if we need a serialized section at all in the boilerplate. So we have here a test plugin that is the plugin we are using to explore the concept of parameters. But let's have another test, which I will call serialize is weird. And I will try to set something like sample rate is equal to srate. Srate is a variable given to us by Reaper that is the sample rate. And I will have no serialize section. Now, if I remember correctly, the behavior is that sample rate will not be set. Oh, sample rate is set. So that was not it. Maybe it was the number of channels. Again, the same as srate, this is a variable given to us by Reaper. And this one holds the number of channels. In this track, for instance, the number is 2. There are 2 channels in this track. And there you go. Value here is 0. This number is not available on the init section, but it is handy to have the number of channels in the init section because there are many things that you would like to initialize based on the number of channels on the track. For instance, you may have a filter and you would like to filter all the channels the same way. So you would like to initialize the filter here, allocate that memory for the coefficients of the filter in the init section. So you would like for this variable to exist. And the tricky thing about this test is that if I save the plugin, or maybe if I hit play, maybe if I do a full compile reset, maybe if I command click on edit, it's not happening. I remember being able to set this variable by chance for some reason. It would pick it up. I don't know. It's weird. Anyway, if I remember correctly, having a dummy serialized section makes this work, and it does. See? Now the value is 2. Let's reload this from scratch because you never know. And there you go. It is 2. Now, according to Tails' email, maybe the first time this block runs, it sets number of channels to 0, and then serialize runs, and then this runs again, and then the number of channels is set to 2. So let's experiment with the x_no_init variable, setting it to 1, and see if this still holds. And let's hope that it does. Okay. So my previous explanation was wrong. This block only ran once, and still this was available. Now, the last test is, if we keep this and get rid of that, do we still have the number of channels available to us? We don't. So I think that this confirms that we want a dummy serialized section in every plugin. Yeah, even if we don't store anything in the serialized section, we'll have a dummy one. Let's come back to test and start fleshing out this lovely picture. We will want to have 2 kinds of sliders, 2 kinds of parameters. The first is parameters that are for that instance, regular parameters. The second is parameters that are linked across all plugin instances. I will have volume, and I will have, let's say, attack. Attack of 5 milliseconds. It can go from 1 to 10 in steps of 1. And I will say that this is the first one. No, maybe the second. I'll call this not global, I'll call this synced. Why synced? Well, first because it is the terminology that we have used when reasoning about this. But we have been using this terminology when reasoning about this because it is synced across plugin instances, or maybe we should call it linked. Yeah, I'll call this a linked parameter. I don't want to call it globally or something like that, globally linked or anything like that, because the notion of linking depends on the parameter. For instance, on the auto mixer, it's not global, it is group wide. There are this notion of groups. We will not get into that right now, but yeah, there is this notion of groups. And then a linked parameter may be linked across all plugin instances. It may be linked across all plugin instances on the same group, or something else. And I chose attack because, again, it is something that has a unit of measurement that is probably not the unit of measurement we would like to actually use in the processing of audio. We would probably want to convert this into samples. So with that, there is some notion of derived parameter. And Aria is here. Hello, Aria. How are you doing? So Tail is talking about his example code that logs when each section is running. And it also shows that serialize is called on undo, slider changes, etc., not just on project load and save. Yeah, that's true. And perhaps it also interacts with autosave. So perhaps serialize will be called, well, I guess you could argue that it is called being on save. It's just that save is happening on the background from time to time. But yeah, I guess serialize would just be randomly called whenever. And Mage is pointing out that we could add counters to each section, but that's not the whole story, right? It's not just knowing that the section ran. It's more detailed than that. In many cases, we want to know the order. So it's when things are running. The order in which the sections run will affect the results. Yeah. Yeah, that's the explanation you gave on the email, and I believe that could be true for the other thing we did where we were using the serialize section to sort of set a flag and then read that flag on the init section and then try to do version migration, try to do saving or restoring stuff from GMM. But I don't think that that's the case because I don't think the init is called multiple times. Well, I am an over-deleter, aren't I? Let's recreate serialize is weird. And so this is Mage's idea, just having a variable that increments. So to begin with, it will be 0, but then it increments by 1 every time the init section runs. So this tells us how many times the init section ran, but not necessarily in which order with respect to other sections of code. But still, this should be good enough for this test. So Let's pop back into Reaper. Yeah, I can reload it, but I think it's better to just get it from scratch. So the init section ran once, and the number of channels is 0. Then, so far, Tails explanation holds. Now we add a serialized section, and then we expect the init section to run twice. And it does. The init section runs twice. But I think that setting this variable will make it only run once, and I think we will see init ran 1, number of channels 2. And if we see that, then I'm right. Init ran 1, number of channels 2. So yeah, I guess I am right. And the explanation is not that the init section ran twice. The explanation really is that when you have a dummy serialized section, the meaning of number of channels becomes available on the init section for no good reason. I'll keep this plugging around if you want to do some more experiments. Yeah, as for me, I recently started my Reaper configuration from scratch, as one does from time to time. As you can see, I didn't change the toolbars anymore. I used to, but I didn't change them, and I'm not missing it. Another thing I did not do was enable SWS autocolor. Aria used to complain that my Reaper sections are too gray, and I guess they're back to being too gray. And to be honest, it's fine. I don't know. I guess I'm a simple person. Oh, awesome. So let's continue. So we have the two kinds of parameters, the instance parameters and the linked parameters. And then when the plugin is loaded for the first time, the init section will run, and it will only run once because we set the x_no_init in the library. We are making the executive decision that you should be using x_no_init for reasons that I explained last week. Yep, it's right here in the library. And the library is being imported in this plugin, so you're good to go. And that means that in the init section, we now need to do this work of, I guess, the star and dagger that are becoming the same thing, which is this work of copying things around and whatnot. And I'm looking at the rest of the actions, and we know that we will need to do star under other contexts. So we'll need to do star here, we'll need to do star in the slider section, we'll need to do star when we are in the GFX section. So let's have this as a function because it will be reused. And we want this function to be called on the init section, and functions can only be called after their declaration. So while in JavaScript we could have a function f and call f up here, that's valid JavaScript, not the syntax, but the meaning of this is valid in JavaScript because of something called function hoisting. It's super interesting. But anyway, this is valid in JavaScript. It's not valid in JSFX. So may only call functions that have been declared above. And this is strictly above, by the way. There is no recursion in JSFX. Anyway, the thing is, because of all this, we must define this function up here in the init section. Now, perhaps confusingly, I would like to call this function slider, because the meaning of the slider section is sort of to compute these derived parameters and blah, blah, blah that we are going to do right now. In fact, that was the function name I was giving it here. But now that we learned that we want to compute this even in the init section, perhaps slider is not the best name. And because we're not in the library, I will not use this prefix, but I guess I will call it parameters. And then in here, we will want to do what we are calling star. So from the sliders, well, I guess let's start with this synchronization. Should we do this E being derived from A, or this E being copied into A, into the sliders? Let's first check that. So we will need to have a place in the global memory where we store this. And I'll call this gmem initialized and gmem attack in milliseconds. Now note that these are not the values of these things in gmem. These are the indices into gmem. So that means that we will look at gmem, which is the global memory, in case you don't know. And we should have options gmem equals something like that. Is this the right way of doing it? Yes. So we will want to look at initialized. And if it has been initialized, we will do something. Otherwise, we will do something else. If gmem has been the indentation is wrong. If gmem has been initialized, it means that we probably want to copy from gmem into here. Oh, hang on, this whole gmem stuff is something that we only want to do once in the init section. It should not be part of the parameters function. If gmem has been initialized, then take the globally synced the linked parameter from gmem, like so. If it has not been initialized, it's the other way around. And we set gmem initialized to true. See what I'm doing here? It is the implementation of that concept where we check a flag in gmem, the gmem initialized flag. And if it has not been set, then do this, where you copy the slider into gmem and you set that flag. But that only happens on the first instance that loads. Subsequent instances will see that flag already set, so they will take gmem as the source of truth and copy that into the slider. So this arrow here is reversed. Oh, all right. So now all of you can go to the forum, the Reaper forum, and look at the order in which the different sections of a JSFX run, I guess. The different sections run. All right, so let's continue with our parameters function. So we already took care of this A to E. Now we need to take care of A to B, and that's dependent on the kind of parameter, but that's super easy to do. We will have something like attack, or I guess even for volume, we'll have volume in linear, and we'll just call the library function db to linear. I was about to write db to liafac to linear of dash. And the same for attack. I guess this line is not going to be the same at all. Attack in samples is milliseconds to samples of attack milliseconds. Not sure if this is how you spell milliseconds. Anyway, that's how to compute the so-called derived parameters. So that's A to B. Now A to D is actually conditional. We saw this here. We don't necessarily always want to copy this. So I guess I will not do it in this function. The reason why we don't necessarily always want to copy this is that D may have a finer level of granularity than A. A is quantized, and D may not be. For instance, in this case of volume, it is quantized to 0.1 and attack is quantized to 1 millisecond. But the GFX notion of that may be in between. Again, for reasons that I explained last week. But all of that means that we don't want to copy stuff into GFX right here. Or maybe we will want to have parameters to the we will have parameters to the parameters function. Because there are cases so this line is probably only useful once. No, not really. This line will be useful to sync the parameters, and this line will be useful to sync the parameters as well. So I guess this whole thing will not necessarily only run in the init section. It may run more often, but not always. Not every time that we call the parameters function. So I guess the parameters function will have a couple arguments to indicate whether we want to run this kind of thing. And for that reason, we'll also write into the GFX notion of these two variables. And it may be the case that we want to do this opposite thing here, where we copy things this way. Yeah, so I think that now the parameters function is encapsulating every movement we would like to make with the variables. When you tweak a slider on the custom user interface, you would like to sync that with the JSFX sliders. That's here. Then there may need to be some interaction with the synced parameters. That's here. Then there may need to be some derived values. That's there. And then this is when you do some programmatic change to a slider and you would like that to be reflected on the user interface. I guess I'm gonna reorder these things, because then it becomes just copying stuff around. And I guess I can even reorder it like this. No, I want this in this specific order, because if you are writing into the global memory, then I may need to have copied stuff from the user interface before. And if you are going to write into the user interface, you may have needed to read stuff from the global memory before. I know, it is super confusing. It's just the nature of what we are doing. There are 5 different things we have to keep track of. Well, 4 now, but still, it's complicated. And I guess this needs to come here, because when we are doing this, we will want to, no, when we are doing that, we will want to quantize stuff. We have a function called slider that helps us quantize stuff. I'm inlining these variables again to try and simplify things. Guess I will even inline this one. And in this case, the length parameter is global, so we have only one initialized spot. But when you have the group parameters, each group will have to have its own initialization. Yeah. Yeah, it's good to spend time reading code. Yeah, I'm really liking the way that this is shaping up. It's telling the story much better than everything we had before. Then we know that in the init section, we will want to run this function, because we will specifically want this part. And I guess let's have a similar story for this slider. Yeah, I'm not sure I want to do the quantization here, but That will do for now. And I guess the parameters function is not something that I will be able to abstract into the library, just because there is no notion of first class functions. So for instance, this is something that is very specific, and this even more so, very specific to your plugin. So there is no way for me to receive this block of code as an argument in my function and then run it at the right time. And even this, yeah, most of this is very specific to the sliders you have. But I guess what we can abstract into the library is this structure. It will not be reified, it will not be code, but we can have this boilerplate as a way of showing how things should be done. It's not ideal, but it's the best I know how to do. And I hope that John Matthews from Toucan Studios is dealing with one of these issues right now with linked parameters on the user interface. Hopefully, if we figure this out and have a solid answer, he will be able to pick this up, even if he's not using the library. I know he's not using the library, but it can be useful nevertheless. Anyway, so we know that we want to run this function right on initialization because of this. We'll also want to run this function on the slider section. It more or less is the slider section. Anyway, then serialize is dummy. Perhaps you can tell that this test plugin is becoming like the example boilerplate for using the library, right? So perhaps what we want to do here in the serialize section, instead of just having 0, which is a good no-op, let's have another no-op that is even better, which is no-op make number of channels available in init. Much more self-explanatory. Then in the block section, we want to call the library. In the GFX section, we want to call the library. And then we have this is slider needed situation. Oh, on the block section, we actually want to call the parameters. I know, it's not ideal. But it's not ideal because it's going to be a lot of work to be computing this over and over. But we want to compute this because of this line. It may be the case that you need to copy stuff from the global memory into the plugin, because another plugin may have written stuff into the global memory by the means of this line. Then, we'll probably want to have the previous values of these variables to run these sections conditionally. Well, I guess they shouldn't be like that. They should be undefined to begin with. Boy, that's a heck of a lot of code just for treating parameters. But so it goes, right? When people are writing plugins, they always tell you that the user interface is the most difficult part, and we are not even dealing with parameter management and presets and whatnot. I mean, not parameter management, preset management. It's a nightmare. Yeah. All right. So with these previous variables that we update here, that we check there, we only compute the derived parameters when necessary. This is crucial because here we are doing very simple derived parameters, but we know that in real plugins, this will be like computing the coefficients of a filter or something like that, and that's expensive. So we want to do this conditionally. And especially if we are doing this on every block. And this is kind of also expensive, so we would like perhaps to save that. But that's impossible because we cannot know if this has been updated unless we check it. Well, that's not the expensive part. This is expensive because this line is going to run often in the block section, and it is accessing the global memory. So that's kind of expensive, but there is no way you are around it because we have to know if the gmem has been updated to update our sliders. So there is no way of preventing that cost. And this is kind of cute in the sense that it prevents us calling the parameters function, but if you're calling it on every block, we might as well just call it on every GFX because it's just a user interface, who cares? So this is a cute idea, but I'm gonna get rid of it as part of like the template. Yeah, so far so good. And this interactive area thing is something that I will want to generalize so that I can have two sliders. So I guess I will rename GFX interactive area into GFX volume dB interactive area. Here, I'm getting rid of this fine adjustment variable because it will be used here as well. I'm still not sure I want to do this here, but anyway, I would just use this instead, which is something given to us by GFX by the means of this function call. Yeah, right. Anyway, this is us updating that notion. Seems about right. Perhaps we could update this here instead. That can be cute. Yeah, I stand by that. We will want to run this conditionally because as soon as the plugin loads, this block is going to run, and we want to avoid running slider automate in that case, but I think it's cute that that's there. Then we can update this variable, but we don't have to do that because this will be done here. Yeah, I stand by that. And the same story here. Then we can even get rid of some parentheses. Isn't that great? That is great because now everything that has to do with updating one slider is right here on this little block. It is a kind of a big block, but anyway, it is right here. And then we call parameters to actually compute stuff, and then we start drawing things. I really like the way that this section reads now. Call the library, then do some management of the user inputs for that button. Then compute the parameters, which means start drawing now, and then draw stuff. Yeah, that looks really good. There is only one problem, and that is in the parameters function, it's not always the case that we want to run this whole thing. We want to have bits and pieces. We could extract the bits and pieces into auxiliary functions, or we could have this as parameters. So I guess let's show what this means. We could have something like hello. I don't know what to call this, so I'll call it hello. And then this goes there, and we call hello here. But if we know that somewhere we will need only this part, we could call hello directly. That's the auxiliary function approach. I'm not sure I love it because I'm pretty sure there will be some parts that need to run like intertwined. So I don't want to have that. Instead, I will just have arguments to the parameters function. So let's think about the cases in which this function is called. And it's pretty much called in every section of code. It's pretty much called in every section of code. And we need to consider each call, and we need to consider what code we want to run and what code we don't want to run. In the init section, which code do we want to run? we don't want to do this. Because this is copying stuff from the GFX section and overwriting the slider that had the good default value to begin with. So that's not what we want to do. We want to skip this. Let's take note. Then do we want to do this? Yes, we do. We either want to initialize the global memory, or we are a plugin that should be reading from the global memory, so we should be doing this. So this we want to do. This, do we want to do that? Yes, we want to initialize the graphics here. So that's something we want to do. Do we want to compute the derived parameters? Yes. But do we want to do slider automate? No, we don't want to do slider automate. So skip on init. And we also want to do this. Perfect. On the slider, that's a block that is called when you move sliders around. But only when you move sliders for real, right? If you change the value of a parameter programmatically, this section is not called, right? I think that's what I want. That is what I want. Okay. Slider has already been called 3 times. But that's okay, it's just the initialization stuff. And as I move the slider around, it is being called often. But when I click, the slider is moving, but the slider section is not being called. Okay, that confirms the behavior I expected. So in the slider section, we will call this. What do we want to run? Do we want to run this? No. Do we want to run that? Yes. Do we want to run this? Yes. Do we want to run that? We will want to skip this on slider as well. How about this? We want to run that. Then on the block section here, starting to notice a pattern. We want to skip this on the block section. Do we want to run that? Yes. And this we don't always want to run. Only if we changed something. So maybe we should put this here. So that we only update the user interface in case the variable underneath has changed. And we also want to keep the slider automate on the block section. And this we want to run. Okay. Then finally, there is the call here in the GFX section. This we don't want to skip, but we wanted to skip this everywhere else. So I don't think it belongs here. I think it belongs there after all. Yeah, looking good. Then, and I think I prefer to have things here because then this whole keyboard control is kind of next to each other. Yeah, I think that I prefer to organize the code this way. Yeah, I stand by that. And then there is this slider automate thing. And this. Slider automate. Do we want to change that? Do we want to run that in the block section? We may. No, actually, no, we don't. We don't. Because the block section may have changed this parameter because of links that link parameters globally. And we don't want that to appear as if you are moving around the slider, and we don't want for that to show up in the param section. So it seems as though this is another thing that we only want to run in the GFX section. So it comes back here. Things are going up and down today, up and down. Like that. I don't love this repetition, but getting rid of it, I think, makes the code even worse. Lovely. I like the story that this function tells, and I didn't have to pass parameters here to conditionally run things. Now the question is, does it work? Well, we'll see. And John is here. Hello. It's great that you are here. I mentioned you a couple minutes ago saying that perhaps we will nail this relationship between all the parameters and where they occur and how they sync. Perhaps we'll nail it. I think we are about to nail this notion. And then it's something you can borrow for limiter tree and the whole nightmare of linking the parameters on the maximizer option. Well, let's see if this works. So the easiest is the thing that is not linked, which is the volume. So let's see if that is making sense. We have to keep track of the JSFX sliders, the derived parameters, and the GFX notion of that. We don't have to take care of GMAM because that slider is not linked. So we only have 3 places to keep track of. Let's see if these 3 places are handled correctly. Volume dB is 0. And the volume in linear is 1, because if you convert 0 dB, you will get 1 in linear. Now, as I move this, I expect this number to change, and I expect this number to change, and I expect this number to change too. And they all change. So these two are in sync. This changes to reflect that, and this changes as well, which makes sense. Let's put this at -6, and then the linear should be 1/2, and it is. Awesome. Then I should also be able to move this around, and this should go with that, and it goes. And then here, let's put this to -6. So you can see now the thing I kept bringing up, that the GFX notion of a parameter may be in between the quantized steps. So right now it's in 5.22, even though the actual slider is at -6. And you can see me moving around this when I move slowly. Awesome. And then this moves around with that, and this is following, right? Is it? It is. Let's put this back to 0. And yeah, everything is following. So yeah, the sliders, the slider, the derived parameters, and GFX are in sync. Great. Now let's implement the user interface for the linked parameter and see if that works as well. So we have to deal with this, but instead of volume dB, it will be attack ms. And I will want to shift this to the right. So let's say that this is like 20. And all of that looks good. This looks good. Well, I guess. The attack will not go from -200, it will go from 1 to 10. And the default is 1. No, default is 5 milliseconds. Default is 5. And oh, I had this line here, but I sort of repeated it there anyway. And then that's that for user inputs. Now let's draw this. Okay, we have the parameter. It is here. Now let's have another instance of this guy. And John, the notion that we have here is to link parameters across plugin instances, which is a much more complicated problem, but you can follow this same approach and have this, instead of linking with the global memory, just link with two sliders in the same plugin instance. Anyway, let's see if this is working. So now we have 4 things to keep track of: the slider, the graphics notion of the slider, the derived parameters from the slider, and the linking of the slider, which is the gmem notion of that slider. Let's follow this first instance and filter for attack. Can we make everything visible at once? Almost. Moment of truth, let's see. First, let's play around with the slider. And the slider doesn't want to move. That's interesting. Then let's play around with the GFX notion of the thing. The GFX notion of the thing does not want to move. Let's play with the other instance. Same story. Interesting. This doesn't want to move. Why would that be? That is because when we are doing this, I was thinking of the initialization of the plugin. I was thinking of what happens in this case where the parameters is being called from the init section. And in that case, I want this to occur. But when I am changing the slider, this will run, and I don't want this to occur. I only want for this to occur in the init section, because I may have to read stuff from the global memory, because I may be the second instance of the plugin that is running, so I need to sync with the source of truth. So I want this to run in the init section. I don't want this to run in the slider section. But I do want this to run in the block section. And I also want this to run in the GFX section. No, because then I am also changing this. In fact, in the GFX section, I have changed this, and I don't want my change to be overwritten. So I only want this line to only run in the init section and in the block section. And this only runs when the global memory has not been initialized, but this only happens once. So perhaps this should be in the init section. Fair enough. And with that, do I have to check this? I don't think so. I think that this will always be true. When we get to that point of calling this, this will always be true because we have initialized it, so there is no point in checking this. Am I forgetting some of the edge cases? I think I'm not. And I guess that's the rule. And I could, like, there was before a case in which we found some lines in here that we only wanted to run in the GFX block. So we cut and pasted lines below. But in this case, we want to run this in two sections and we don't want to run it in two other sections. So I guess this is a good candidate for a parameter. I'm going to call this read mode if I am in read mode. And if I am in read mode, I will sync from the global memory into here. Otherwise, I would say that I'm in write mode. Oh, but then this also needs to occur. Should I have the semicolon here? What's the correct JSFX syntax? If I don't want to have the parentheses because there is a single statement, I think I don't want this line. I don't want this semicolon. But on the other hand, this is a statement. Well, I guess there is no such thing as a statement in JSFX. Everything is an expression. So I think that this is the right way of writing this. Anyway. Right, I think I captured this correctly. But I'm not 100% sure because it is a bit tricky. Oh, and when we have more global parameters, we will want to have multiple lines. So I'll write it like this. Yeah, I think I stand by this. So in the init section, I am in read mode. And in the slider section, I am in write mode. And then in the block section, I am in read mode. Like that. And then here I am in write mode. So I say false. Okay. Let's give this another try. But before I do that, I do want to read the comments because maybe I made a mistake and someone already corrected me. Cool, I will have to review from the start to see what you're doing. Well, it is tricky, I will tell you. Parameter sharing across instances already appeared sometimes in my plugins. Interesting, I wonder if you arrived at a similar solution as to what I'm coming up with. And I don't like how this line is repeated. I guess I could extract this into an auxiliary function. Because the more parameters we have, the longer this gets, and it gets a bit annoying. Yeah, I'll leave a to-do here. Try and remove the repetition. But let's test if this even works. So loading. Now I'm at least able to move this around, and that's great. And I will move this to H, and then we expect for the other one to be linked. Yay! When it loads, it is correct. And I can move this. I can move that. And they are linked. And everything is going together. Oh, there is a bit of a glitch because of a race condition between the GFX section and the block section. So the GFX section is calling parameters in read mode, in write mode. God damn it. The GFX section is calling parameters in write mode, but the block section is calling it in read mode. So it ends up overwriting this variable. Yeah, we still have not arrived at a good solution. Is at least the derived parameters moving with? So let's look at attack in samples. It is moving with, and that's even on the other instance. So that's indication that things are going well. But there is some sort of race condition going on, and there is this repetition. How do we deal with this race condition? The parameters function is called in multiple places, and that's a problem that John is going to be familiar with, because the problem is that the parameters function is being called at the same time from the slider, from the block section as well as from the GFX section, and they are clashing. So ideally we would like to call this function as a critical section, like a mutex kind of thing, where this function can only be called from one place at a time. But that introduces a lock on the audio thread, which is a bad idea. So instead, we will have to come up with something else to try and make this item potent. Reentrant? Not even sure what the right buzzword is here, but there is a problem with the parameters function, a problem that John and I talked about before many times. Okay, that's all I have time for today. This has been a fun exploration, but we have been here about 1.5 hours at this point. So I will cut this short now. I'll leave myself 2 to-dos. The first is this, try and remove the repetition of this line. And the second is the race condition between GFX and block. Tomorrow we'll not get back to this code. Tomorrow we have a meeting of the Digital Signal Processing, C++, JUICE, and many other things study group. So tune in tomorrow for that. We'll have updates from everybody. It will be a lot of fun. Then perhaps on Thursday, we will be back to this. Before I leave, let's see what people had to say. I was gonna say, like, the multiband compressor has parameter linking, and that took John all of 3 seconds to implement once I asked for it. Yeah, but I'm already reviewing the whole BuzzTools plugin. Limiter tree is already done, and sync is working fine. Awesome. I set a flag to not call the function again to avoid thread collision. Yeah, so John is following an approach that we may explore on Thursday, and that is to... It is similar to a flag that we had in GFX and I removed today, the like need to call this function flag. The problem is that sometimes you are bypassed and the user interface is showing. So you're not processing audio, but your user interface is showing. So you should be calling that function to do the linking from the user interface. But sometimes your plugin interface is not showing, so GFX is not running, but the block section is running because audio is being processed. So in that case, you would like for the syncing of parameters and everything to occur in the block section, and therein lies the problem. Anyway, that's all right. Bo is focusing on mixing, and yeah, everyone is saying their goodbyes. So see you tomorrow for the study group, and thank you all for joining me. Aria, Tail, Mage, Bo, John, you are the best. Looking forward to seeing some of you tomorrow. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.